Hello guys, welcome to Pharmaprofin. In today's lecture, we will discuss about drug receptor. There are four types of drug receptor: inotropic, GPCR, protein kinase, and intercellular. I will tell you all about them. Just be with me. So first, we will discuss about the inotropic receptor. The inotropic receptor is composed of five units: alpha, beta, gamma, delta, and epsilon. So it's a pentameric structure. These are locked. When there and how this works? Let's say mechanism. Whenever the ligand bind to this site, look at it. When ligand bind to this site, then this locked receptor opens. Let's say it's a locked receptor, and when ligands bind to this receptor site, and it's open like this. Okay? And then ion influx happen, and then the signal transmission carry forward. Its excitatory or inhibitory will depend on the ion type. For example, look at here. Whenever there is sodium influx, what will happen? It will happen excitation. And if there is a chloride channel influx, it will happen hyperpolarization. Signal will be inhibitory. Okay, and example are GABA receptor also, serotonin receptor also. So it is the most simplest type of receptor. Just bind to the receptor site and it open and conduction happen. Okay, and is the fastest in action. Its action happen in milliseconds. Okay, now we will move toward our second lecture. G protein couple receptor. Okay, now look at here. Is the most complicated receptor here. This is composed of 7 transmembrane protein. 1, 2, 3, 4, 5, 6, 7. Okay, these are embedded into the cell membrane. So look, whenever the ligand bind to the receptor, this signal is carried through this transmembrane protein and reach here to the G protein. Okay, and in G protein there is these three subunits: alpha, beta, and gamma. I have mentioned here alpha and beta gamma together because when signal comes here, this bond, alpha beta bond, breaks. Okay, and one unit become alpha and another unit become beta gamma. Okay, now I'm telling you to focus on why I have mentioned it here two subunits, because when alpha subunit breaks, it create GS and GQ type of G protein. Okay, and when beta gamma subunit form, it create GI type of protein. When GS type of protein activate adenylyl cyclase, which start the CAM pathway, and GI also activate the CAM pathway, but it decrease. So it inhibit the adenylyl cyclase and it activate the adenylyl cyclase. GS and GI both work the same principle, but just one is increasing, another is decreasing. Okay, but GQ type, it's work by activating phospholipase C, and its action is through IP3 and dark channel. This will you will understand in systemic pharma more detail. For here, most example we should learn about this are for GS type, beta 1, beta 2 adrenergic receptor, beta 1, beta 2. We will learn is all about beta blockers in CVS chapter in systemic pharma. And alpha 1, alpha 2. Alpha 1 is best example of GQ type of receptor, and alpha 2 is best example of GI type of receptor. Unlike the inotropic receptor, this receptor is not that much fast. Its response time is seconds to minutes, and it also requires secondary oxygen. That's why it's slow. Okay, now we'll move on to our third type of receptor, which is protein kinase receptor. Okay, the protein kinase receptor. Here the protein word is for the receptor, and kinase word is for the enzyme. Like look at here. Okay, you can see this is two arms of the receptor. Okay, why I am mentioning is two arms. You will see the mechanism and you will understand. Look, whenever two ligands bind to two receptor, okay, two ligands will bind to two receptor, okay, they will bind, and then the receptor will fuse, okay, fusion of the receptor, and then will be enzyme will be activated. The kinase here will be phosphorylation and it will activate it, okay. And one thing I forgot to mention, that protein kinase channel, the main purpose of this channel is to create the cell division inside, okay. The main purpose is cell division. So whenever body needs growth or metabolism, the cell division will occur. It is a natural found in every organ. Okay? But one thing which you should know about this: if this channel, protein kinase receptor, get mutation, a serious type of disease happens. I will tell about that later. First of all, example, JAK-STAT pathway also known as I will tell them about later. Jexstat, tyrosine kinase. These are the all protein kinase receptor example. Okay. Now what I was telling about earlier. BCR ABL fusion. You will learn this about in pathology, in hematology. There are two types: chromosome number 9, chromosome number 22. Okay, 9 and 22. Okay, these just like there, they fuse, and they create BCR ABL gene. Okay, BCR ABL gene. But this is a result of mutation. Not naturally, they should not. Okay, and this mutation cause a serious disease, chronic myeloid leukemia. This type of blood cancer. So yes, this is a if this receptor got mutation, a serious disease like blood cancer can also occur. Okay. Now our last receptor, it is an intracellular receptor. There are two types of intracellular receptor: intracytoplasmic and intranuclear. In intracytoplasmic, as name suggests, ligand will bind to the intracytoplasmic receptor. Most favorite example are steroidal hormone like progesterone. But look at here, the progesterone I have written here, but estrogen is not. Estrogen is in the internuclear area. Okay, you should remember estrogen act through internuclear. Okay, internuclear will cross the nuclear cell membrane and nuclear membrane both, and will act on direct inside the nucleus. Now let me summarize everything from the beginning. Inotropic receptor, 5 pentameric units. When open up, ion influx will start, and signal excitatory or inhibitory will decide on the ion type, and it's the fastest action, act in milliseconds. Okay. Now, G protein coupled receptor, transmembrane protein, ligand will bind, and alpha beta gamma unit will split, and G protein type is depend on alpha or beta gamma. If alpha is forming, then GS and GQ will form, which will activate adenine cyclase and phospholipase C, which action I have written here. It's slow comparison to inotropic. Okay. Now, last protein kinase and intercellular. Protein kinase, two receptor to ligand fusion, and then activation of enzyme, cell division occur, and if mutation happens, then serious CML type chronic myeloid leukemia or blood cancer can also happen. And last, intercellular receptor divided into intracytoplasmic and internuclear. Intracytoplasmic on direct inside the cytoplasm action, like most steroidal hormones like progesterone. Estrogen is I have put on here on the intranuclear side, not on the intercytoplasmic side. Okay. And best example are for internuclear is thyroid and estrogen, and for intercytoplasmic it's progesterone. Okay, and it's the slowest acting receptor. I think with this lecture and with these notes, you will able to write about the drug receptor in your university exam, and if any most important MCQ will come, you can also do that. Thank you.